This is the screencast for section 4.8, example 3. We're going to use some trig to find the height above the ground of a lovely penguin inflatable balloon in a parade. A large helium-filled penguin is moored at the beginning of a parade route awaiting the start of the parade. Two cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground, and are in the same plane as the perpendicular line from the penguin to the ground. So in other words, we don't have to worry about 3 dimensions here. This is all a flat, we can draw this on a piece of paper as if it were a flat plane. Ground 10 feet from each other. How high above the ground is the penguin? So what I've drawn here is my cute little penguin, and here's the cable that makes a 48 degree angle with the ground, and here's the cable that makes a 40-degree angle with the ground. The distance between these two people holding these cables is 10 feet. And we are looking for x, the height. Well, we still need to consider d, the distance that this closer float holder is from the perpendicular down from the penguin, because it will be part of the adjacent side of both the 48-degree angle and the 40-degree angle. The algebra on this one is going to get a little intense. So first I'm going to set up two, similar to example, I believe it was 2, I'm going to set up 2 different tangent equations because I'm dealing with 2 different triangles. So first I'll say the tangent of 48 degrees equals its opposite over hypotenuse, x over d. Then I'll say the tangent of 40 degrees equals its opposite, also x, over, now this time it's going to be d plus 10. Now we have 2 variables in both equations, so I'm going to approach this by setting them both equal to x, then setting them equal to each other, solving for d, and then using my value for d to plug back into one equation and getting x, and I'll show you. So if I solve these both for x, this one is going to be d times the tangent of 48 degrees equals x. So I'm going to multiply this by both sides by d plus 10. And now since both equations are solved for x, if they are both equal to x, they are both equal to each other. So I'm going to say that d times the tangent of 48 degrees, tangent of 40 degrees. Now, this is where things get a little bit more complicated, because now we have to solve for d, but there's a d on each side of the equal sign. So I'm going to start writing over here, actually. I'm going to distribute on the right side of the equation. So I have d times the tangent of 40 degrees plus 10 times the tangent of 40 degrees. Now I'm going to get this term with the d also on the other side. So I have d times the tangent of 48 degrees minus d times the tangent of 40 degrees equals 10 tangent 40. Now I can factor out, since I have d times something minus d times something, I have a common factor here of d. So I'm going to factor out d, or undistribute. Now I can divide both sides by this difference, and I get d. D is going to be 10 times the tangent of 40 degrees all over tangent of 48 minus the tangent of 40. Now, when I put that in my calculator, I get about 30.90, but that's d. That is the distance from the first guy to the perpendicular down from the balloon. I don't want d, I want x. So I'm going to save that value in my calculator and use that in the easier formula over here, where I can just plug in d and multiply times tangent of 48. Actually, so I'm plugging in 30 times 0.90 times the tangent of 48 degrees, and I will get what x is. So using this exact value from my calculator and multiplying by the tangent of 48 degrees, I get that x is about 34.32 feet. So that's how tall the balloon is through the parade. Now, the now try problem number 15 is going to talk about some civil engineering. The angle of elevation from an observer to the bottom edge of the Delaware River Bridge, so here's the observer, up to the bottom edge of the bridge, which is 200 feet from the observer, is 30 degrees. There's that. Then the angle of elevation from the observer to the top observation deck is going to be 40 degrees. And I'm going to call that distance from the bottom to the top x, because that's what we're trying to find. What is the height of the observation deck? How tall is this deck from bottom to top? So I'm going to set up two expressions again. The tangent of 30 degrees is going to be its opposite over adjacent, b over 200. Then the other one, the tangent of 40 degrees, is going to be its opposite, which is x plus b over 200. Now what's nice in this one that we didn't have in the last example is that there's only one variable, 200 times the tangent of 30 degrees. I can plug that b value in for this b value. But first I'm going to solve for x on this side so that when I plug in the values for b, it's not as messy. So I'm multiplying both sides by 200. And then I'm going to subtract b. So 200 times the tangent of 40 degrees minus b is x. So 200 times the tangent of 40 degrees minus 200 times the tangent of 30 degrees, which is what I found b to be from my other triangle setup, is x. When I plug that in my calculator, I get that x is about 52.35 feet. So the height of this observation deck is 52.35 feet.